Hey guys, my name is Laith Metalka, and I am currently in genetics. I'm here to talk about replication, transcription, and translation. So before we get started, we have to talk about the central dogma. Central dogma basically states that DNA goes from DNA to RNA to proteins. So from DNA to DNA, it's replication. From DNA to RNA, transcription. RNA to proteins is going to be translation. So DNA is this helical structure. Kind of looks like this. So first we're going to have this helicase enzyme comes in like somewhere in here, and it's going to start unwinding this long strand of DNA. And as it does that, it's going to create tension up and downstream. So we're going to need another enzyme called the DNA gyrase. The gyrase is basically going to relieve that tension. So as the DNA unwinds and it's breaking the hydrogen bonds between the base pairs, you can have these single-stranded proteins hold that DNA down. So as you see here, you have a double-stranded DNA. You have this is the non-template strand. This is the template strand. We'll get into that down here. And so you have the binding protein, the single-stranded binding proteins over here and here. And then we have something else that's really important. It's the primer. The primer basically is the jump start to the DNA polymerase. Okay, and so let's get into an example. So you have the non-template and then the template strand, and so you have the sequence ATTC from 5' to 3' and TAAG 3' to 5'. So the DNA polymerase, you see that primer over here? The DNA polymerase is going to come in. It's going to start replicating from 5' to 3', so it needs a complementary strand to that, which is the 3' to 5'. So it's going to come in and replicate, so ATTC. And that's kind of replication. So the next step of the cycle is DNA to RNA. But specifically in this situation, we're going to talk about mRNA. And this is called transcription. So basically, the DNA has a promoter region and a termination region. So the promoter region tells the RNA polymerase, hey, come here, come bind and start making messenger RNA for this important strand of DNA. So basically the RNA polymerase is going to come here, and this does not require a primer. It's really important. It's going to come by here. It's still going to replicate from the 5' to 3'. The promoter region tells the RNA polymerase where to bind. So it's going to bind right afterwards, right after the promoter region, and it's going to start replicating on the 3' and the 5' end. The 3' and the 5' end. This is going to create the mRNA. And so the difference is that for the base pairing here, there's going to be no thymine, and it's going to have A and uracil is going to bind together. Okay, so now we're going to get into translation. Translations from mRNA to proteins. So there are 3 steps to translation. You have the initiation, elongation, and the termination. So you have different little components that come into it. You have the ribosome, which is composed of the small subunit and the large subunit. You're going to have the tRNA, which basically transfers the amino acids, and this has an anticodon. We'll talk about this later on. And we're going to have the start sequences. You have ATG and the stop, which is these 3. And so you have this mRNA that we just made from transcription. So you have the small subunit come in, and it's going to bind to this 3 base pair sequence, which is a codon. So with 3 base pair sequence, it's going to codon, and that small subunit is going to bind to that ATG. Then you're going to have a tRNA come in, which is going to have the anticodon to this codon. And so ATG codes for a methionine amino acid. So that tRNA is going to come in, it's going to bind. So now what we have here is you have this tRNA, it's in this P site, excuse my drawings, it's in this P site, and it has the methionine amino acid. So once that comes in, the large subunit's going to come in. And it's going to have this is supposed to be an A, it's going to have the E, P, and A site, just like in the small subunit, but the small subunit does not have the E site. This is important for later on. So now we're going to start the elongation. So you have this large subunit connected to a small subunit. So in this A site, we have another coding for another amino acid. So that's going to bring in another tRNA with another amino acid, and that's going to come in over here in the A site. So once that comes in, the methionine from the P site is going to transfer to the amino acid tRNA on the A site. Okay? So once that comes in, this is going to move one codon forward. The tRNA in the P site move into the E site in the large subunit, but there's no binding site in the small subunit, causing this that used to be in the P site to the E site to leave. So this is going to keep going. Then the next amino acid is going to come in the A site, and then it's going to come in the A site, and then the amino acids from the P site is going to transfer to the A site, and then it's going to rotate one codon forward one more time, and the one in the P site is going to leave. This is going to keep on going until you reach a stop codon. Let's say UAG or UGA. Let's say that stop codons in the sequence. So once that occurs, once this sequence comes in, it's going to cause the small ribosome and the large ribosome to disassemble, and that is basically translation.